In 1969, NASA's Wernher von Braun designed the exact Mars architecture SpaceX uses today. Reusable rockets, orbital refueling, multi-ship convoys. Every major Starship innovation already mapped out 50 years ago. But here's what most people don't realize. Von Braun's plan solved critical problems that SpaceX is still struggling with. Here's the smoking gun. When you place von Braun's 1969 Mars architecture next to SpaceX's Starship blueprint, you're looking at virtually identical engineering solutions, just with different fuel types. Von Braun's nuclear shuttle system? 3 cylindrical stages clustered together, outer boosters separate and returned for reuse via controlled return burns. Sound familiar? It's exactly Starship's booster catch system, except von Braun designed it 50 years earlier. But here's what few people realize. Von Braun even calculated the exact same orbital mechanics SpaceX uses today. His departure window, November 12, 1981. SpaceX's preferred windows follow identical Earth-Mars alignment cycles. Because physics doesn't change. Von Braun's 9-month transit time? Same as Starship's planned journey. The man literally wrote the playbook. And here's the kicker. Von Braun's payload calculations prove SpaceX didn't just copy the concept, they copied the math. His 726,000 kilogram Mars spacecraft versus Starship's 1,200,000 kilogram fully fueled. When you factor in nuclear propulsion's 2 times efficiency advantage, the payload ratios are nearly identical. This isn't coincidence, it's engineering plagiarism. But wait, there's more. Von Braun's Mars excursion module, 8.8 meters high, 50,900 kilograms descent weight, designed for 30 to 60-day surface stays. SpaceX's Mars Starship variant, 9 meters diameter, similar mass budget, same mission duration. Even the landing approach matches, atmospheric braking with parachutes and retro rockets. First major difference, artificial gravity. While SpaceX accepts that crews will arrive at Mars weakened after 9 months in microgravity, von Braun solved this in 1969. Connect 2 ships nose to nose, spin the 164-meter structure, instant artificial gravity. Why did SpaceX ignore this proven solution? We'll come back to this critical oversight. Second shocking parallel. Redundancy planning. Von Braun designed 2 identical ships flying in convoy for rescue capability. SpaceX's original Mars architecture? Multiple Starships in formation flights. They're literally following his safety protocols. And here's what most people overlook. Von Braun calculated 950 Saturn V launches to assemble his Mars fleet. SpaceX claims they need hundreds of Starship flights for Mars infrastructure. Same scale, same approach, same logistical reality. But the most damning evidence, von Braun's propellant choice reasoning. He selected nitric acid/hydrazine because it could be stored without refrigeration for 3-year missions. SpaceX chose methane/oxygen for the exact same reason. Long-term storage capability and Mars fuel production potential. But this is just the beginning. What's really surprising is why SpaceX chose to copy this specific 50-year-old plan when NASA had dozens of Mars studies to choose from. Here's where Elon Musk's true genius emerges. He didn't just randomly stumble onto von Braun's architecture. He deliberately selected the one NASA Mars plan that could work with private funding and modern technology. Why this plan specifically? Because von Braun solved the fundamental economic equation that killed every other Mars proposal. NASA's 1990s Mars missions required $400 to $500 billion in government funding. Von Braun's reusable architecture, updated with modern manufacturing, drops costs to under $100 billion. That's the difference between impossible and achievable for a private company. But here's what few people realize. Every other space company missed this connection. Blue Origin's lunar focus, Virgin Galactic's suborbital tourism, ULA's traditional expendable rockets. They're all competing in markets von Braun had already moved beyond in 1969. SpaceX recognized that Mars colonization was the ultimate market, and von Braun had already solved the technical framework. And here's the kicker about timing. NASA abandoned von Braun's plan in 1972, not because it was technically flawed, but because it required sustained political will across multiple presidential administrations. Apollo succeeded because it had a deadline: beat the Soviets to the moon. Mars colonization needed a different motivation structure. Musk cracked this code by creating artificial urgency. Humans must become multiplanetary before catastrophic events threaten Earth's civilization. It's brilliant marketing wrapped around von Braun's engineering, creating the sustained funding source NASA couldn't maintain. First strategic advantage SpaceX gained: they could cherry-pick von Braun's best ideas while discarding expensive elements. Nuclear propulsion? Replace with cheaper methane engines, accept lower efficiency. Complex rotating habitats? Skip artificial gravity, accept crew health risks. Von Braun's government budget allowed luxury. SpaceX's private funding demands compromises. Second masterstroke: vertical integration. Von Braun's plan required coordination between NASA centers, contractors, and international partners. SpaceX builds everything in-house, eliminating the political complexity that killed the original program. But there's a detail most people overlook. SpaceX's innovation timeline perfectly matches their access to declassified NASA documents. The Starship concept emerged shortly after von Braun's detailed technical specifications became publicly available through NASA's archives. Coincidence? Hardly. The competitive implications are staggering. While other space companies spent decades developing incremental improvements to existing rockets, SpaceX leapfrogged straight to the final architecture. It's like skipping from horse-drawn carriages directly to Formula One racing, because someone already designed the Ferrari 50 years ago. And here's what's truly noteworthy about the business model adaptation. Von Braun's plan assumed unlimited government funding for a scientific expedition. SpaceX flipped this into a commercial colonization venture, creating revenue streams from satellite deployment, space tourism, and Mars cargo delivery. Same technical foundation, completely different economic engine. The implications extend beyond SpaceX. NASA's current Artemis program increasingly resembles von Braun's modular approach: orbital assembly, reusable components, redundant systems. They're rediscovering their own 50-year-old innovation because SpaceX proved it works. And here's why this changes everything for the entire space industry. Understanding that SpaceX essentially modernized a 50-year-old blueprint doesn't diminish their achievement. It reveals something far more significant about the future of space exploration and the patterns that predict success. Here's what happens next. Every major space power is now scrambling to implement von Braun-style architectures. China's Mars plans mirror the multi-ship convoy approach. NASA's Artemis borrows the orbital assembly strategy. Russia's reviving nuclear thermal propulsion. The entire industry is converging on solutions von Braun mapped out in 1969. But there's a problem most people don't see coming. SpaceX copied the technical framework, but ignored critical elements that could doom their Mars ambitions. Von Braun's artificial gravity solution prevents bone density loss, muscle atrophy, and cardiovascular deconditioning. Starship crews will arrive at Mars significantly weakened, potentially unable to perform complex surface operations. And here's the kicker about radiation exposure. Von Braun's rotating spacecraft provided natural shielding through mass distribution. Starship's vertical orientation leaves crews exposed to cosmic radiation for 9-month journeys. Multiple missions could exceed safe lifetime limits, fundamentally constraining colony population growth. First major prediction: SpaceX will eventually adopt von Braun's dual-ship configuration for crew safety. Current single-ship missions work for initial landings, but sustained colonization requires redundancy. When the first Starship experiences life support failure en route to Mars, they'll remember why von Braun designed backup systems. Second inevitable development: artificial gravity integration. As crew health data from long-duration Mars missions reveals the true cost of microgravity exposure, SpaceX will retrofit rotating capability. The physics von Braun calculated in 1969 doesn't change. Human biology demands it. But here's what few people realize about the timeline implications. If von Braun's program had continued, we'd already have sustainable Mars colonies producing fuel, growing food, and expanding human presence across the solar system. Instead, we're celebrating SpaceX's promise to maybe reach Mars by 2029, using the same plan from 1969. Why would this delay matter for humanity's future? Because the window for becoming multiplanetary might be narrower than we think. Climate change, nuclear weapons, asteroid impacts, pandemics, the existential risks von Braun and Musk both recognized are accelerating. Every decade of delay increases the probability that Earth-based catastrophes could end human civilization before we establish backup colonies. And here's what's truly noteworthy about the economic implications. Von Braun's nuclear thermal approach offers 2 times the fuel efficiency of SpaceX's chemical rockets. For sustained Mars operations, this translates to dramatically reduced fuel production requirements, faster cargo deliveries, and lower operational costs. SpaceX's methane choice optimizes for development speed, not long-term efficiency. The most profound realization: we're not witnessing revolutionary space innovation. We're watching the methodical implementation of a 55-year-old master plan, updated with modern materials and manufacturing techniques. Von Braun had already solved Mars colonization. We just needed the technology to catch up and the business model to make it sustainable. Looking ahead, the most successful Mars colonization effort will combine von Braun's comprehensive engineering with SpaceX's economic optimization and modern automation. The technical challenges he identified in 1969 remain unchanged: radiation shielding, artificial gravity, redundant life support, fuel production. Physics doesn't care about marketing timelines or investor expectations. The ultimate question isn't whether SpaceX copied von Braun's blueprint. The evidence is overwhelming. The real question is whether humanity will learn from both men's insights or repeat the same mistakes that delayed Mars colonization by half a century. Because this time, we might not get another chance. This is exactly why SpaceX's Mars timeline keeps shifting. They're discovering in real time what von Braun calculated 55 years ago. Every breakthrough announcement, from orbital refueling to multi-ship formations, is actually SpaceX catching up to a blueprint that was completed before the first moon landing. What this means is profound. We're not waiting for revolutionary new technology to reach Mars. The engineering roadmap exists, tested through decades of analysis, refined by the greatest rocket scientists in history. We're simply watching modern manufacturing and private funding finally make von Braun's vision economically viable. The bigger picture: this pattern extends beyond Mars. Every major space achievement, orbital stations, reusable rockets, interplanetary missions, traces back to concepts designed by visionaries decades earlier. We don't need to invent our spacefaring future. We need to execute plans already proven on paper. And this is just the beginning. As SpaceX encounters the biological realities of long-duration Mars missions, they'll inevitably adopt von Braun's artificial gravity solutions. When radiation exposure limits crew rotation, they'll implement his shielding strategies. The blueprint is there, waiting. How do you think this will impact NASA's approach to Mars exploration? Will they compete with SpaceX's updated version of their own 50-year-old plan, or collaborate to finally complete von Braun's vision? This is Space Hub, and we dive deep into the engineering stories behind space breakthroughs. If you want more analysis connecting space history to today's innovations, hit subscribe. For the latest developments in humanity's greatest adventure, you know where to find us. The future isn't being written, it's being remembered, one brilliant design at a time. Boeing's Starliner has faced over a decade of delays, from timing errors that missed the ISS to corroded valves that grounded launches. But these aren't isolated incidents. There's a pattern here that reveals something troubling about how aerospace testing works. Today, we'll trace the chain of failures that show exactly what's going wrong. Boeing's Starliner problems aren't random glitches. They form a troubling pattern that reveals fundamental issues in aerospace development. Let's dissect exactly what went wrong and why it matters. The December 2019 mission failure exposed the most revealing problem. Starliner's internal mission clock was set incorrectly. causing the spacecraft to fire its engines at the wrong moment and burn too much fuel to reach the International Space Station. Think of it like a GPS that's running 11 hours fast. Every navigation decision becomes catastrophically wrong. But here's what few people realize. NASA discovered a second software error lurking in the system that could have caused spacecraft components to collide during re-entry. This wasn't caught until after the failed mission, revealing a deeper issue with Boeing's testing methodology. The root cause? Boeing tested systems in isolated segments rather than running complete end-to-end mission simulations. It's like testing a car by checking the engine, brakes, and steering separately, but never actually driving it. Critical timing and communication problems slipped through because the systems never interacted under realistic conditions. NASA's post-flight investigation required Boeing to implement dozens of changes to their testing protocols, a process that consumed years and became the primary driver of Starliner's schedule delays. And here's what's truly noteworthy. While software dominated the headlines, mechanical failures proved equally persistent. The parachute system, literally the last line of defense for crew survival, suffered multiple critical failures. In 2019, during a crucial pad abort test, one of 3 parachutes failed to deploy due to an incorrectly attached pin. For NASA, this wasn't just human error. It signaled that quality control processes weren't catching life-threatening mistakes before critical tests. 2 years later, engineers discovered that fabric components called soft links, which connect parachute lines to the capsule, didn't meet safety margins for crew missions. Boeing had to completely redesign these components and restart testing cycles, but the mechanical problems extended beyond parachutes. In August 2021, 13 valves in Starliner's propulsion system refused to open during launch countdown. The culprit? Moisture had infiltrated the valves while the spacecraft sat on the ground, mixing with oxidizer to form nitric acid that corroded internal components. This failure highlighted a fundamental design vulnerability. Earth's environment was damaging spacecraft systems before they even reached space. Boeing had to develop entirely new inspection methods and consider design modifications to prevent future occurrences.